Good afternoon, everyone. We are back again. Remember last time we did theorem 1 and theorem 2, and I even introduced you to some basic, basic information about pretend. So today we are going to do theorem 3 and theorem 4. So now this is theorem 3. It says if a line is drawn if the line is drawn from a circumference if a line is drawn from a circumference and passes through the center of a circle, the line shall give us a semicircle. In other ways, what we are trying to say, sometimes English can be somehow, but what I'm trying to say is that if a circle is drawn and there's a center of a circle, I mean a line that starts from the circumference and it passes through the center of a circle and it's going to touch another circle. Therefore, we are going to have angles in a semicircle. These are angles in a semicircle. We have O, we have D, we have E, we have F. Isn't it? These are the 3 points. Remember that DE is a diameter. Do you get it? And again, remember theorem 3 is similar to theorem 2. So I'm going to use an equation of theorem 2 to prove theorem 3, whereby it says an angle at center is double the one that is in the circumference, is twice the angle in the circumference. So now what does it tell us? Remember that a straight line is equals to 180 degrees, isn't it? The very same straight line, even under, is the same as 180 degrees, isn't it? So if you look at your diameter, remember here we also have 180 degrees, isn't it? We said an angle at center is twice the one at the circumference. So let us check again. We have, what is our, let's say this is O1, this is O2. Let's say O1 is double of F. And then we are going to say the value of O1 is equals to 180 degrees, equals to double of F. Do you get? For us to get rid of these two, what do? Either we can say we multiply by the reciprocal or we divide by 2 both sides. What you do on the left, you also do on the right. As you divide both sides by 2 and you divide by 2, these 2 will cancel that 2. Therefore, angle F will be equals to 90 degrees. It means that an angle there will be equals to 90 degrees. Reason being, these are angles in a semicircle. Isn't it? So this is theorem 3. Proving using theorem 2 to prove theorem 3, where it talks about angles in the semicircle. And then we have again theorem 4. We have theorem 4 that says if the line, if the chord and the tangent of let me say if the chord and the tangent are in contact, in the circumference of the circle, and an interior angle of triangle, an interior opposite angle of a triangle is equal to the exterior angle of a triangle. What do I mean by this? If you have a circle and then we have a center, and then there is a triangle and there is a tangent that touches the circle at one point. We have A, we have B, we have C. Isn't it? Therefore, the angle A will be equals to angle C. Why? Because of they are subtended by the same chord. Do you get it? Therefore, A is equals to, let's say this is C1, this is C2, this is C3, is equals to C3. Which means you are going to say tan chord. Do you get it? This is your reasoning when it comes to theorem 3 and 4. Let's hope everyone enjoyed their lessons. If you don't understand, if you need more information under Euclidean geometry, you can inbox me. This is Tsepo my info. Then I hope we shall meet even in the next hours or in the next weeks or in the next days. Shalom.